let's do a quick recap of what we studied last week. Okay, last week we learned about organic chemistry, and then we also learned about the economics of the chemical industry. Okay, so let's begin. Okay, the first question, what is organic chemistry about? Anyone can answer? Okay, good. Organic chemistry is the study of carbon containing compounds. Okay. It is the study of carbon containing compounds. Okay, moving on. Next question. State three characteristics of the homologous series. So when we learned about organic chemistry, we learned that there are millions of organic compounds, and these organic compounds are put in groups or families called homologous series. Okay, so the question is asking you to state three characteristics of the homologous series. Can I have the answer for this, students? Okay, I do see some answers. All right, good, everyone. So homologous series. Homologous series is a group of organic molecules with similar chemical properties same general formula and same functional group. Okay, so these are some of the three characteristics of the homologous series. Now you can also write about the physical properties. Okay, as I told you, you cannot write the physical properties are different. You have to say that the physical properties change in a gradual way. Okay, or the physical properties change in a regular way. And there's also another characteristics, which is the neighboring molecules differ by a CH2 group. Okay, so that means the molecule just right after it will have a difference of one carbon atom and two hydrogen atoms. Okay, all right, well done to all those who answered. Next question. State the general formula of the alkane homologous series. Can I see an answer? Good. It's CnH2n plus 2. Okay, moving on. Why are there so many carbon compounds? Give three reasons. Okay, so we learned that there are so many compounds of carbon, so much so that one branch of chemistry is dedicated to the study of these carbon compounds. Okay, so give three reasons why there are so many carbon compounds. Okay, can I see your answers? Okay, good. I do see some answers. Okay, so you can say carbon atoms form multiple bonds. Okay, carbon atoms form single, double, and triple bonds. Okay. Okay, the next reason, they form long chain compounds. Then they form ring chain compounds. Okay, so these are the three reasons why there are so many carbon compounds. Okay, let's move on to the next question. Why are alkanes called saturated hydrocarbons? Now, alkanes are hydrocarbons because they only contain carbon and hydrogen atom. Okay, but the question is, why are alkanes called saturated hydrocarbons? Okay, who can answer? Okay, good. They are called saturated hydrocarbons because they contain only single bonds. Okay, so in alkanes you can only find single bonds. All right, good. Okay, next one, name the first 5 alkanes. So the last class we learned the names of the alkanes, right? Okay, can I see your answers? Remember, we had that memory aid, monkeys eat peanut butter. So you can use that memory aid to help you to name the first 5 alkanes. Okay, very good. I do see a few answers. Okay, that's methane, ethane, propane, butane, and then pentane. Okay. All right, good. So all those who answered all the 5 alkanes correctly, well done. So you're doing some revision, yeah? Okay, I can see that. All right, the last question. What is the molecular formula of butane? Okay, so we learned that from the general formula, it is very easy for you to write the molecular formula. Okay, so what is the molecular formula for butane? Okay, good. But means 4 carbon atoms. So butane will be C4H10. All right. So well done to all those who answered. Those who are not able to answer, make sure you revise. Yeah. So, you know, you're not left behind. Okay. So let's move on to today's lesson. So today, what we will be learning is about the structural formula and properties of alkanes. Okay. And this will be the last part of our topic for the CT1. Okay, so I have already shared the link with you in your WhatsApp group and the school EMS system and also during the lesson. So make sure you download the notes and keep it with you. Okay, all right, so let's move on to drawing the structural formula. Okay, so when you learned in organic chemistry, we learn about calcium carbonate, sulfuric acid, sodium chloride, potassium bromide, and so on. So there we focus on the chemical formula. Okay, but when you learn about organic chemistry, we also have to focus on the structural formula. Okay, so the last lesson we learned how to write the molecular formula. So today we will learn how to draw the structural formula. Okay, so the structural formula is the structural formula is the way describes the way the atoms are arranged. Okay. Okay, so when you draw structural formula, make sure you know the molecular formula first. So once you know the molecular formula, it's easy to draw the structural formula. Okay, so many times I've seen students, if you're asked to draw the structural formula, they just sit down and look here and there. All you need to do is write down the molecular formula, then you quickly get an idea of how to draw the structure. Okay, so now let's look at how the structure can be drawn. Okay, now the first alkane is methane. Okay, and we know that methane has only one carbon atom, and carbon atoms form 4 bonds. So this is the structure for methane. So you can see that one carbon atom and joined to 4 other hydrogen atoms by single bond. So this is the structure of methane. Okay, now moving on, let us look at the structure for ethane. Okay, so as I told you earlier, the structural formula shows the atoms and bonds in a compound. Okay, is that clear? So C2H6 is the molecular formula. So drawing it in a way by showing the atoms and bonds, that's the structural formula. Okay, C2H6, since you have 2 carbon atoms, it's ethane. All right, now when drawing the structural formula, the easiest way to draw it is to first draw the carbon atoms, okay, the carbon skeleton. So C2, so 2 carbon, and then after that you attach the hydrogen. Okay, 1, 2, 3, 4, 5, 6. Okay, so now you have C2H6. Now once you have done that, okay, once you have completed, make sure you count the bonds. Okay, each carbon atom should have 4 bonds. Okay, 1, 2, 3, 4. Again, this carbon, 1, 2, 3, 4. Is that clear? Okay, now there's also another way of writing the formula. Okay, so this is a condensed way. This is a simpler. This is a simpler way of. This is also another way of writing the formula. So let us look at how you can write this formula. You see here, you have 1 carbon and 3 hydrogen atoms. So it is kind of condensed, CH3. Okay, so you write the CH3. Then you have the single bond. And then again, you see on the right-hand side, it's again CH3. So you have the CH3. Okay, so when you count the atoms, you will still get C2H6. Is that clear? So if you come across a formula like this, don't think that you have not learned this. You add up all the atoms and see to which alkane it belongs. Is that clear? So now, since you're learning about alkanes, it will be this molecular formula will be connected to CnH2n plus 2. Okay, so later when you learn about alkenes, the general formula will be different. Is that clear? So how do you know that this is ethane or any alkane? You add the atoms and see, then you can, when you look at the molecular formula, so you'll get the idea of what compound it is. Okay, so that's for ethane. Okay. Now let's move on to 3 carbon atoms. Okay, 3 carbon atom is propane. Again, the same way, you draw the carbon atoms first. Okay, you draw the carbon atoms first, and then you add the hydrogen atoms. You will get the structure. Is that clear? And always you must make sure that carbon has 4 atoms. So let us say you draw the structure. You draw the structure, all the carbon and hydrogen atoms, they are correct for propane, C3H8, but you put a double bond here, or you put a double bond here. You will not get full marks, okay? Because then you see carbon here will have, this carbon will have 5 bonds, this carbon, all the carbons, they seem to have 5 bonds. Okay, so no marks will be given. Okay, so though it's a very simple structural formula, if you are not careful with the number of bonds, you will lose marks. Okay, all right. Now again, you see the way the formula is written. Okay, the simpler way of writing the formula. You see here CH3. Okay, so CH3. Then here you have CH2. So CH2, and then it's CH3. Okay, so when you add up the atoms, it will go back to C3H8. So if you come across a situation like this, you add the atoms and see, then you will know which compound it is about. Is that clear, students? Okay. Now, so the three examples given here are methane, ethane, and propane. So will you be able to draw for other alkanes? If you're asked to draw for butane or pentane or hexane, will you be able to draw? Yes or no? Yes. Okay, good. All right. I don't think they will ask you to draw for C20. Okay, then you'll be drawing this whole page will be full of carbon atoms. I think the maximum would be a hexane or hexane. Okay. Is that clear? All right. So drawing the structural formula for alkanes is the easiest, because so far will be the easiest, because you only have carbon and hydrogen atom, and there are no double bond or triple bond. You only have single bonds. Okay. So you just have to be a bit careful. Okay. So here a little bit of notes for you to remember. So whatever I said just now, that's the same thing that's here. So when drawing the structural formula, you should show all atoms and all bonds. Okay. Sometimes the question will specify draw the structure of propane showing all atoms and all bonds, but sometimes they don't say, but whatever it is, to be on the safe side, you just draw the structure showing all the atoms and all the bonds. Okay. And also, as I told you earlier, there can only be 4 bonds around each carbon atom, not 5 bonds or 3 bonds. Okay, just be careful with these small things, and then you'll be fine. Okay, so now moving on, we look at the physical properties of alkanes. Okay, so when we say physical properties, we will deal with whether the particular substance is a solid, liquid, or gas, melting point, boiling point. Okay, so these are the melting point, boiling point. These are the things that we will be concerned about. Okay, so that is what physical properties about. So let's look at the physical state. Remember, when we learned about the homologous series, we learned that the properties of the physical properties change in a regular way. So let's see how the physical properties are going to change in a regular way. Okay, now when you look at alkanes, the first 4 are gases. Okay, so it says here C1 to C4 as a short form. It refers to the number of carbon atoms. Okay, so the meaning is that methane, ethane, propane, butane. These 4 are gases. All right, so these 4 are gases. C5 to C16, it's not 17, C5 to C16. So from pentane, so pentane onwards, it is a liquid. Okay, so C17, 18, C17 onwards, it's a solid. All right, so you don't have to know the names of the alkane with 16 carbon atoms and 17 carbon atoms. Okay, so not to worry about that. You just need to know the molecular formula. If it is C17 onwards, means it will be C17H36. Okay, so C17H36, C18H38, it will go on like that. Okay, is that clear? So quite easy to remember. The first 4 are gases: methane, ethane, propane, butane are gases. Pentane to C16 liquids. C17 onwards, they are solids. All right, so these gases, those that are gases, are the ones that we use as commonly as fuels, the fuels that the Bunsen burner fuel. Okay, and then the fuels that come to our homes, the gas cylinder fuel. So all these are all these will be one of these gases. Okay, and then C5 to C16, one of it is kerosene. Kerosene is a fuel that is used in kerosene lamp. Kerosene is also used as a fuel in jet engines. Okay, now C17, you can find compounds like bitumen. C17 onwards, you find compounds like bitumen, and bitumen is used in making roads. Okay, so these are the physical states of alkanes. Okay, so now let's move on to the So this will be the first one. Okay, the second one will be the melting and boiling point. Okay, the second property is the melting and boiling point. Now, as the number of carbon atom increases, the melting and boiling point increases. It's obvious, yeah, the melting and boiling points increase. Now, who can tell me why the melting and boiling point increases when the number of carbon atom increase? You can see the graph here. You don't have to sit down and memorize this graph. This is just to give you an understanding as how when the number of carbon atom increases, the boiling point is increasing. Okay, all right. So now let's come back to my question. Why do you think when the number of carbon atom increase, the melting point and boiling point will increase? Okay, more energy is needed to break the bonds. Okay, so here you have to be careful. All right, so over here, what is you're partly correct. More energy is needed to break the break something, but it's not the bonds. What is being broken is the intermolecular forces of attraction. Okay, so intermolecular forces means forces of attraction that are found in between the molecules. Okay, for example, if you say interclass competition in year 11, so it means the competition is between the classes 11-1, 11-2, between 11-1 and 11-2, 11-3, like that. Okay, it's not inside the class. So intermolecular forces means forces of attraction between the molecules. For example, if you have methane molecules, let us say you have we'll write it like that. So you have a mixture of you have methane molecules in an area. Okay, so there will be forces of attraction. So there'll be forces of attraction between the molecules themselves. Okay, so this is what you call as intermolecular forces of attraction. So you need the energy to overcome these forces of attraction. So in between the molecules. So this is what you call as intermolecular forces of attraction. Okay, all right, so let's look at the explanation here. Now alkanes have weak intermolecular forces of attraction, and these intermolecular forces of attraction are also called van der Waals forces of attraction. Okay, so the intermolecular forces have another name, which is van der Waals forces, based on the person who discovered these forces of attraction. Okay, so the answer is here. So the reason is that the intermolecular forces of attraction, when the number of carbon atoms in the molecules, okay, so increase in the number of carbon atoms in the molecules. When the number of carbon atom increases, the intermolecular forces of attraction become stronger. So more heat energy is needed to overcome these forces of attraction. Okay, so if you write more energy is needed to break the bonds, you will not be given marks. You have to say more energy is needed to break the intermolecular forces of attraction. Okay, all right. Okay, so now let's move on to the next property. As the number of carbon atom increases, the density will increase. Obviously, each carbon atom has its own mass. So when the number of carbon atom increases, the density will also increase. But nevertheless, some alkanes are very low densities, a density which is even less than the density of water. Density of water is 1 gram per cm cube. So if the density is less than 1, some alkanes can even float on water. Okay, so again, when the number of carbon atom increases, the density increases. Okay, next one. As the number of carbon atom increases, the molecules, they become less flammable. Okay, it becomes more difficult to burn. Okay, because there is a higher percentage of carbon atom, and not only that, even if they burn, they burn with a smokier flame. Okay, the flame becomes very, you won't see a clear flame. The place will be full of smoke. Is that clear? Okay, so that's the third property. And the last one is alkanes are insoluble in water, but they're soluble in organic solvents such as CCl4. So CCl4 is carbon tetrachloride. Okay, so carbon tetrachloride. Now NaCl, you call it as sodium chloride, right? Okay, so carbon, this is carbon tetrachloride. Okay, sodium chloride is not an organic compound. Okay, so this is just to give you an example. Carbon tetrachloride. Tetra means 4, mono means 1, di means to di refers to 2, tri refers to 3. Okay, tetra is 4. What about 5? What is 5? Good, 5 is penta. Okay, so you can see here there are 4 chlorine atoms, so it's carbon tetrachloride. Okay, now can you name another organic solvent, a common organic solvent? Okay, so they are alcohols, yeah, ethanol, or generally alcohols. All right, so these are also organic solvents. So alkanes do not dissolve in water, but they dissolve in organic solvents. All right, okay, so this is 5, sorry. Okay, to summarize the physical properties, though there are quite a bit of explanation, basically when you summarize the physical properties of alkanes, physical properties, okay, when you summarize this one, this is what you will get. C1 to C4, they are gases. C4 to C16, liquids. C17 onwards, solids. Okay, then melting point, boiling point, density, increase with number of carbon atoms. Okay, then you can say insoluble in water, soluble in soluble in organic solvents. Okay, so though you have quite a bit of explanation there, this is the main idea. Okay, so the state of the gas, the melting and boiling point, the solubility. So if you know these, then you can answer questions for the physical properties of alkane. So they can ask you, what is the physical state of hexane at room temperature? So hexane has 6 carbon atoms, so it is in this category here. So it is a liquid. All right, so they can ask you, what is the physical state of propane at room temperature? Propane has got 3 carbon atoms, so it is a gas. Okay, so these are the kind of questions they can ask. All right, or they can ask you, why is the boiling point of hexane higher than that for ethane? So you write about the intermolecular forces. Okay, you write the explanation based on the intermolecular forces. Okay, so these are the kind of questions that you would get. Okay, students. All right, any questions on the physical properties before we move on to the chemical properties? Okay, now when what do we learn when you talk about chemical properties? What are we going to learn? Who can tell me? Physical properties, we learned about density, melting point, the physical states, and so on. What about chemical properties? Okay, good. Chemical properties, we learn about the chemical reactions of substances, how the substance reacts with another substance to form compounds. Okay, good. So let's look at the chemical properties of alkanes. Now, alkanes are generally unreactive. Okay, they don't form, they don't have that many reactions. Okay, so that means they do not form so many other compounds. Okay, all right. Now the reason is they have strong carbon to carbon bonds and carbon to hydrogen bonds. Okay, for example, if you look at ethane, you take the structure of ethane, see. So here you can see the carbon to carbon bonds and the carbon to hydrogen bonds. Okay, so these bonds are not easily broken, so they don't have that many reactions. So they're generally unreactive. Okay, so in a way good for us also. We don't have to learn that many equations also as well. Okay, so but nevertheless they do have some reactions. Okay, for this in this particular topic you learn about two reactions. Okay, so the first one is combustion. Okay, so combustion, who can tell me what is combustion? When you say combustion, what it is about? A reaction with oxygen. Okay, so it's reaction with oxygen. So alkanes, when they react with water, they form, alkanes, when they undergo combustion, they react with oxygen to form carbon dioxide and water. So this is the general equation. So here you have methane. Okay, so here you have, this is a formula for methane. So methane, when it reacts with, when it undergoes combustion, it forms carbon dioxide and water. Okay, water vapor, but even if you write water, you'll be given marks. So it's water in the gaseous form, water vapor. Okay, and you can see here that the delta H value is negative. 890 kilojoules of energy is given out. Okay, so this is a highly, so this shows it's a highly exothermic reaction. That means when methane is burnt, it will react with oxygen in the air to form about 890 kilojoules of energy. And this is the reason why alkanes are used as fuels. They make good fuels. Okay, now before we go into the fuel part, who can answer my question? So here, this is methane plus oxygen gives carbon dioxide plus water. Okay, now propane plus oxygen forms what product? Propane plus oxygen. Okay, who can give me an answer? Yeah, it's carbon dioxide plus water. Okay, same product. Okay, do not think that because it is propane, the 3 carbon atom, you have a carbon trioxide and things like that. It's no. Okay, so when there is enough oxygen to burn, alkanes, they react to form carbon dioxide and water. Okay, the products are the same, but when you write the chemical equation, the way you balance it will be different. So you have to pay a bit of attention to that. Okay, all right. So now let's look at a little bit of definition for fuels. Okay, so what is a fuel? A fuel is a substance that reacts with oxygen to release energy. Hydrocarbons that you find in crude oil. Crude oil is a mixture of hydrocarbons. So the crude oil, the hydrocarbons, they make good fuels, especially if the molecules are small. Okay, so what is a fuel? It is a substance that reacts with oxygen to release energy. Okay, all right. Now, what is the fuel for our body? Food. Yes, yeah. So you can see that during respiration, what happens? The food is digested to simpler molecules called glucose. So glucose reacts with oxygen to form carbon dioxide, water, and energy. Okay, so we use that energy for our daily activities. The carbon dioxide we exhale, the water also goes out of our system. Okay, all right. Okay, so now let's look at a little bit more on this combustion part. So when we learn about combustion, so there are two types. Okay, so combustion can be complete and combustion can be incomplete. Okay, so let's see what these are. So when you look at complete combustion, okay, complete combustion is where there is enough oxygen. Okay, complete combustion, when you have enough oxygen, all of the carbon atoms will burn. So when you have enough oxygen, all the carbon atoms in the fuel will burn, and therefore you will get carbon dioxide and water. Okay, so let us take the Bunsen burner as a good example. So in the Bunsen burner, there's fuel, right? So the fuel burns, and then you see the flame. Okay, so when the air hole is completely open, so this is the air hole, when it is completely open, there's enough oxygen going in, and then the fuel will burn, and therefore you can see a blue flame. Okay, so if the air hole is not if the air hole is not completely open, what will be the color of the flame? So there's also another color for the Bunsen burner flame, right? You must have seen it's blue. Yes, it's orange, yellow, or orange. Okay, so the blue flame of the Bunsen burner is a good example for complete combustion where heat energy is given out. So, uh, uh, so during complete combustion, what are the products that are formed? Carbon dioxide and water. Okay, so hydrocarbon. So the hydrocarbon can be any hydrocarbon. It can be methane or propane and so on. Okay, so you get carbon dioxide and water. Okay, so these are a few examples. Okay, so for the earlier part, so methane, I've mentioned this many times. Methane is a hydrocarbon, and it is found in natural gas. So when methane undergoes complete combustion, carbon dioxide and water are formed. Propane is a hydrocarbon. It can also undergo combustion. Okay, so what is the balance symbol equation for the combustion of propane? Now, who can tell me the symbol equation for propane? Okay, C3H8 plus oxygen. What products are formed? Carbon dioxide plus water. So how to balance this equation? Okay, so I do see some answers. 5, 3, 4. 5, 3, 4. Let's check. Yeah. All right. So you have on the reactant side, you have 3 carbon atoms. So here also 3 carbon atoms, 8 hydrogen atoms here, 4 times 2, 8 hydrogen atoms. Then here 5 times 2, 10. 10 oxygen atoms, right? So here 3 times 2, 6, 6 plus 4, 10. Okay, good. So this is how you write the equation and you balance the equation. Okay, all right. So now let's move on to a little bit more on incomplete combustion. Okay, so incomplete combustion is when there is not enough oxygen. Okay, incomplete combustion takes place when there is not enough oxygen. And during incomplete combustion, what happens? Instead of carbon dioxide, carbon monoxide is formed together with the water. Okay, so remember, during complete combustion, you get carbon dioxide gas, and during incomplete combustion, carbon monoxide is formed. Okay, all right. Now, carbon monoxide is a poisonous gas. Now, who can tell me why is carbon monoxide a poisonous gas? You must have learned this before, or you must have read this somewhere. Yeah, carbon monoxide is a gas that can kill people. Okay, so so carbon monoxide complete combustion is preferred when compared to incomplete combustion, because carbon monoxide will be formed if the fuel doesn't burn properly. Gas fires and boilers must be serviced regularly to make sure that they do not produce carbon monoxide. Okay, so gas fires that are produced by using alkanes, those alkane gases. and boilers are places where water is heated, okay, where by using coal or by using natural gas. So these must be serviced properly. So if they don't work properly, the gas might not burn well, and instead of producing carbon dioxide, it can produce carbon monoxide. Okay, that is the reason why while cooking also we need to make sure that the windows are open and we have a good supply of air. Okay, because cooking gas is also are also hydrocarbons. Okay, all right. So another thing that you need to remember here is that we learned that during complete combustion, you have carbon dioxide gas. So during incomplete combustion, you get carbon monoxide. Sometimes carbon can also be formed. Okay, so this is the equation. When you are writing, if carbon monoxide is formed, your equation appears like that. And if it is carbon, so your equation can be like this. All right, so so you need to be careful as to what product you have to write. So read the question carefully. The question will sort of guide you towards what product you have to write. So first you have to see whether it is complete combustion or incomplete combustion, and generally, and if they say gas, then you write about carbon monoxide. If it is just a solid particle, then you write carbon. Okay, I'm sure you all know that carbon is a solid. Okay, so to kind of simplify it, so we can say complete combustion, complete. You have complete combustion, you have incomplete combustion. Okay, so complete combustion product is carbon dioxide and water. Incomplete combustion, you can get carbon monoxide, you can have carbon, and of course the water. Okay, so read the question carefully, and the question will guide you towards what products to write. Okay, a little bit on carbon monoxide. Okay, carbon monoxide, we already learned earlier, is a poisonous gas. Now it absorbs in the lungs. Okay, so when people breathe in this carbon monoxide, it can, it gets into the lungs. And one danger of this carbon monoxide gas is that it doesn't have any smell. Okay, now cooking gas, when there's a leakage, you have that smell. But in the case of carbon monoxide, there's no smell. And it quickly will combine with the hemoglobin in the red blood cells. The function of the hemoglobin is to carry oxygen to the body. But when the carbon monoxide combines with the hemoglobin, it cuts off the supply of oxygen to the body. Okay, so when there's not enough oxygen, people initially feel drowsy. Okay, drowsy is like they feel like sleepy, like they have a headache, like that. And then they can fall unconscious and even die. Okay, so that is why carbon monoxide is a dangerous gas. Okay, it's a poisonous gas because it can supply the it can cut off the supply of oxygen to the body. Okay, now a little bit more on carbon. Okay, so we earlier saw that during incomplete combustion, carbon particles are also formed, and these carbon particles are generally called as soot, S-O-O-T, soot. Okay, so these carbon, okay, so these are formed during incomplete combustion. Okay, so this is the equation. Carbon, it can, so this is the equation for the formation of soot or carbon. Hydrocarbon plus oxygen, you get carbon monoxide, carbon and water. So the equation, you can have all the three at one go, or it can be just carbon monoxide plus water or carbon plus water. So as I told you earlier, read the question carefully, see what the question is asking you to write. The question will kind of guide you to write what products. Okay, yeah, all right. Now these you must have these carbon particles. Sometimes, when you burn a candle and then you leave it near the wall, or if you have some glass structure over it, you can see that part is dirty. Okay, so that is actually what you call as soot. All right, you see this picture here, this is soot. Okay, carbon particle. Carbon is a black colored element, so carbon particles. So these are the carbon particles. Okay, now the carbon particles glow in the heat and give it the yellow color. So this is the same thing that happens in a Bunsen burner also. During the complete combustion, all the carbon is burned, so you get a blue flame. During incomplete combustion, the carbon particles are not burnt, and the carbon particles will glow to give that yellow or orange color. Okay, now though carbon particles are not poisonous like the carbon monoxide, they're also harmful. They cause respiratory problems for people. Okay, so if you live in a polluted area with a lot of soot around you, then it's very unhealthy. All right. Okay, so that's about the combustion part. Now, let us look at some uses of alkanes. Now, we have seen the uses of alkanes, learned the uses of alkanes before, but anyway, this is just to, you know, put it together here in one place. Now, methane, it's a major part of natural gas. Okay, so we learned that this natural gas is used as fuel, and natural gas is also used, is reacted with steam in the making of ammonia. Okay, so these are the uses of methane. Propane and butane are sold as liquefied petroleum gas. So these gases, they're converted to liquid, because once they're converted to liquid, it's easy to store them. And these are the gases that come in our gas cylinders. Okay, the cooking gas is in the liquid form. So when you on the gas and start cooking, it will quickly turn to gas. Okay, and the gas burns. All right. Now, butane is used in portable gas cylinders. Okay, portable means the gas cylinders that can be carried around, and also in gas lighters. Is that clear? Okay, so with this, we end the lesson for today. It's almost time. Okay, now, okay, let me summarize what we learned today. So today we learned about the how to draw we learned about how to draw the structural formula for alkanes. Now, one thing, just because it says draw structural formula, you don't have to use a pencil to sit down and write that. You can use your pen and draw the structural formula. Okay, and then we learned about the physical properties and chemical properties of alkanes. Okay, so chemical properties, we learned only combustion, the complete combustion and incomplete combustion, and also the uses of alkanes. Okay, so any question on today's lesson? Okay, no questions. No question. So I want to remind you about this homework. I have shared this worksheet last week, Friday, in your class WhatsApp group. You can also find the link in your EMS system. So have you done this homework? Okay, so what we will do is we will discuss the answers in the next class. Okay, so we have one more reaction to complete in alkanes. Okay, substitution reaction. That's a very it will take about 5 to 10 minutes only. Okay, so we will do that in the next class, that chemical reaction, and with that we will finish off the syllabus for the CT1, and then we will move on to this worksheet. Okay, so those who have not completed, make sure you write the answers. You know, you write the answers in your exercise book. Then we will discuss the answers in the next lesson. Okay, all right. Okay, thank you, students.